Hello and welcome to the third of three presentation days for Capstone. My name is Dr. Robert P. Shoemaker, and together with my co-instructor Dr. Lee Dong Wu, we welcome you to today's presentations. Today we will hear from Aerobicon and Keras sensors, so let's get started. Aerobicon is a home maintenance solution for your septic system. Sometime life throws punches at you, the lights go out, the gutters need clean, the lawn needs mowed, and the list goes on. Aerobicon seeks to alleviate potential stress by giving homeowners the ability to monitor the health and functioning of their septic system. Aerobicon, care for your home because your home cares for you. And with that, I will now turn it over to Mr. Carnes and Aerobicon. Mr. Carnes.
Okay, good afternoon, everyone. My name is Justin Carnes, and today my colleagues and I would like to introduce to you our new device called Aerobicon. So first of all, what is Aerobicon? Aerobicon is an internet-enabled timing circuit replacement for aerobic septic systems. If you're unaware, an aerobic septic system is a septic system that filters and chlorinates wastewater and then disposes of it by pumping it to your yard through sprinkler systems or occasionally leach bed systems. The timing circuit is the part of this system that regulates the activation of the sprinkler system. Typically, the traditional system is a mechanical box that basically looks at the water levels in the tanks and schedules the activation for a set time. With Aerobicon, we wanted to come up with a system that was smarter than the traditional systems. We retain these pump activation settings, but we wanted to do so in a more intelligent manner. We also included 24/7 monitoring of the septic tank system and water levels, and provide email alerts for when things don't go quite right. We wanted to provide all these features in a robust and easy to use user interface that can be controlled from any web browser. The controls for the device are served through a simple but powerful web page design. To deliver on all of the promises mentioned, the device offers the following functionality. As mentioned, the original timing circuits offer scheduled activation, and we wanted to keep this. This is an important feature for aerobic septic tank systems. We wanted to expand it a little bit, though, and offer weather condition activation of the pumps. So, for example, if it's raining outside, some users might not want to spray down their yards with extra water. So the pump would then delay its activation until such time that the weather has cleared up. We wanted to include also some powerful troubleshooting tools. So every time the Aerobicon activates the pump, it writes this information to a log, and users can go in and view logs. If the sprinkler system is not activating when they think it should, they can go look at the logs and see if it was supposed to activate and just didn't, or if the activation got delayed for some reason. To go hand in hand with this, the settings page also offers a test pump button that allows users to briefly activate their pump and make sure it is functioning properly. If they don't notice that the sprinklers aren't activating when they're supposed to, then the tanks will, build water. There's nowhere for the water to go. If this happens, then the overflow switches will be triggered and an email notification will be sent to the user so they can be aware of the problem and either deal with it themselves or call out a professional. For this implementation, the first version of Aerobicon, we decided to go with the Raspberry Pi 3 as our main hardware component. We decided to do this because the Raspberry Pi, we have some familiarity with it already. Shane and myself have worked with Raspberry Pis in the past, and it offers Wi-Fi connectivity and easy manipulation of hardware devices through the GPIO pins. The float sensor communicates input from the septic system through these pins. We flashed the Pi with Raspbian OS, and we decided to go with, for our development purposes, a flavor with a desktop environment. That way we could do a lot of the development and testing directly on the device, which made our lives a lot easier. Our main software package is built on the Node.js framework. This allowed us to have a constantly running server that monitored input and output through the on-off package, hosted a web server through the express.js package, which allowed us to provide the users with access to their settings files and log files, etc. Node Mailer was the package we used to send out the email notifications, and Jade was the package that we used to design our web pages. We had some other supplementary packages, but these four really did the heavy lifting on the project. We also made frequent use of the Open Weather API when we were performing the weather checking for the conditioned activation of the pump. And now at this point, I would like to pass off to my fellow developer, Shane McLean, to talk about the more intricate details of the design and software architectures.
Thank you, Justin. So we're gonna look at our graphic use case model or diagram. So as you can see, we have three, or I guess four main components. You can say we'll have the user interacting with Node.js, which in turn is going to be interacting with the Raspberry Pi. And then you'll have a black box for the septic system, which is going to be interacting with the Raspberry Pi. And then we'll have Open Weather API, which is another black box that we'll be using to interact with, once again, the Raspberry Pi. I should go ahead and say that we're actually going to be moving away from a Raspberry Pi, something that we'll cover later on in this presentation, to another industry standard. I'm going to just leave it as vague as possible so I can allow my team members to cover that. With the Raspberry Pi, it will notifications will be sent to the user if two instances occur. One, if you look at the black box on the right, if float 1 and T1 gets too full, it'll send a notification to the user alerting them that their first or their second tank technically is too full and they need to do something about it. It's not sending water over to the very last tank. Then as well, they will receive a notification if their third tank is too full. It could be a series of different problems, like maybe the pump isn't turning on, or the pump is turning on, but it's not, you can just keep it real vague. Like the pump is turning on and it's not pumping water or something to that degree. So they'll receive and hopefully they'll be able to do something to act upon that via just reaching out via professional help. And then apart from the sending emails, they'll be able to set their settings. And their set settings, one of the things they'll set is their email. Potentially later on in the future, once again, I'm going to allow my other teammates to elaborate on this and later on down the PowerPoint, but we would like to send email, or not only email notifications, but phone notifications. And then they'll also be able to, can you hear me? It was cutting out. I thought I was cutting out. Anyways, they'll also be able to test the pump, which will turn on and off the pump as long as the bottom float is on. So if for some reason the bottom float isn't on, we don't want them to be able to turn on the pump. We don't want them to have the capability of potentially burning up the motor in the pump. And every time the pump is turned on or off, it will record it in the logs. It was something that we were working on. There's a lot of integration that was happening this past couple of weeks, trying to integrate new parts and components into the current machines. So some of it looks pretty good and works really well, and other bits and pieces of it are like, okay, we see the idea and it just needs a little bit of TLC. But you'll see it eventually in the video. And that hits the that diagram. Sorry, it kind of freaked me out when Justin changed. Okay, so we're gonna look at the lifecycle model. We decided to choose was prototyping. It made sense that we could just have several different iterations, and actually we're just caught in the last, just within this week, we're working on another iteration. As you'll see in the video, I'll be able to elaborate a little bit more in there. We were trying to implement some more software, or not software, another piece of hardware due to the coronavirus, being able to get supplies and stuff like hardware needed to build the machine was kind of hard. But the main reason that we decided to implement this new piece of hardware was for the sake of decreasing the costs and making it cheap for me to be able to try to deploy it into my system. So anyways, we chose prototyping because it made sense. We wanted to be able to add on. We wanted to start initially with a timer and then be able to work our way into more complicated things such as the sensor. our architecture that we chose was main program and subprogram. The reason is because we have the Pi that's going to be controlling all the main components to leading out and coming into, leading out of the Pi, going to the septic system and coming back in from the septic system to the Pi. So for instance, receiving input from the septic system from the floats, or in this case, it's going to be the new device, and then turning on the pump as output. So the Pi is going to be controlling that in conjunction with Node.js. If you look at our chart or diagram, Node.js is responsible for serving the web pages that are going to be controlling the user interface. And part of that user interface, of course, is the home page, the settings page, and the logs page. Each one's pretty self-explanatory, and we'll be covering that in the video. Node.js is also responsible for the weather API in terms of putting together a request to get the current weather, excuse me. And yeah, I believe that it touches on what we need to in terms of the architecture. Before we go into the video demo, I just want to once again just touch on the fact that at this time we were caught in the middle of another iteration, so we were wanting to implement more hardware into it for the sake of trying to reduce costs. Let me elaborate a little bit more. The floats that we were looking to buy to put into our septic system were at a low end of $30, high $50 a piece. So we're looking at buying 4 floats ranging from $120 to $200. And this new device that my dad and I, along with the help of Justin, that we were trying to build would cost, I'm gonna leave it more to Josh, but it was really cheap. It was like $30-ish. I'll leave it to Josh and Cody to explain that more. And then real quick, I just wanted to touch on last presentation. One of the questions that was asked was some logistics. So for instance, how are we going to power the Pi? One of the ways that we're going to do that is we're going to be pulling wire and pulling wire from the box and creating a wall outlet to allow the Pi to be plugged into. And then the last logistical thing in terms of attaching the Pi to the septic system is how are we going to turn on the pump? And we're just going to use a relay. We'll have, along with that wall outlet, we'll be able to feed power into a relay, and then using the Pi, we can control whether the relay is on or off, and then direct that power to the pump. So that all being said, let's go ahead and go through this video.
Okay. We had a little trouble getting it to render in our PowerPoint for some reason, so I'm going to drag it from off screen. Hopefully everyone can see. Please let me know if there's any problems.
And due to this was recorded on my phones in terms of the UI, so I'm just going to kind of speak as it's happening. So in here, we're going to Firefox and going to Aerobicon :3000 is the port that it's running on. So everybody will be able to access it via this web address. Here I'm going into the settings page, and I'm just typing in some of my user info to demonstrate that it works. This is something that we did last presentation, the mid-semester presentation. But I just want to demonstrate that it still worked. When we were going through and trying to clean up our code, it actually broke. So it's quite a relief to see this actually working now. So then I'm going to submit it, and it's going to save my information, and I'm going to demonstrate that it was saved by leaving the settings page and going back into it. And as you can see, all of my information is saved. And then from here, I navigate to the logs page. We changed the UI to where it's going to be more of a Dropbox style. So, I mean, in terms of the way it looks. So you'll have like these folders, and you'll just navigate to the folder. It's broken up by year, month, day. And as you can see, I just reached the end of the folder, and it took me to the text file and displayed it. And then I navigate back to the home page and come back in to show that what happens whenever you click on another folder, I believe. I'll wait for that to load. In this process, we created just a generic 404 page to render if the file isn't found. Oh, and then like if there's a folder and it's empty, it'll just display that. So here we go. You got it. It was good. Is the audio playing on it?
Yes. Can you not hear it?
No.
How about now?
Maybe. May need to go further on. No, it's not playing. Interesting. If need be, I can talk over it and kind of give you a general idea. But okay, so here I was just trying to talk about. This is when I was trying to integrate the new device into the system. But prior to that, I wanted to demonstrate that all the floats were working. So as you can see from the prompt, switch 1, 2, 3, and 4. It's kind of shaky. I'm sorry, I'm not a professional cinematographer, but I just want to demonstrate that all the floats were turning on and that the LED was turning on. The LED is the pump or the model for the pump. Let's see. And then I believe, okay, so this is the new device. It has a PVC pipe on the outside and PVC pipe on the inside. And what's going to happen in the end is that magnet that I'm holding is going to be inside of a ring that's buoyant. So as the water level increases, the ring will rise. And as the magnet passes each one of those black lines, it'll turn on the reed switch. And when it does, it'll set a flag saying, yes, this reed switch was crossed, and allow for us to do our basic float logic that we were talking about doing. One thing I mentioned in here is that at the very top of it, we would like to have another reed switch that goes directly from the, well, it's its own circuit. So if it hits the top of it, it'll just turn on the the pump, irregardless of whether or not the pi is on or off. Because what may be happening is when it reaches the top, it may be, the pi may not be firing correctly. It may be completely off, or there might be something wrong with the circuit. So it was just a good fail-safe to have. Linking up properly, and that they were turning on. It was kind of weird because with the floats, the console was clear, and then when I switched directly over to the reed switches, for some reason it was deciding to simply keep on outputting it to the console like it's doing now. This is different, but anyways, it's outputting it to the console. So I just had to do some logic in my code. Here I'm demonstrating or displaying the true on the left is actually if the water level is rising or lowering. So if it's true, it's rising. If it's false, it's lowering. And I was showing all the variables. S1 is the first float. We'll probably have a float in the second tank. The third tank is going to have this new device. So S2, S3, and S4 are the markings on the pipe. Here I'm showing that my email was cleared. Sorry, I'm a little behind. The email is cleared, so I haven't received anything from the Pi. I'm demonstrating that the float is still working with the code, so you can see F1 is turned on. And this is when F1 is turned on, it's supposed to send me a notification to my emails saying that the tank is or the second tank is full. For some reason, it's not moving water over to the next tank. So it takes a little while because we're working with cron jobs, and so it's supposed to check it. And if, how do I say this? the floats and updating them every second, but it doesn't check for an email till a minute later because I just want to kind of demonstrate that we can set different cron jobs to make them work. So I get an email here soon. Shouldn't take too long. And of course, F2, F3, and F4 are off. I'll hold it just for a minute because, like I said, it's supposed to take a minute. So at this point, I receive the email. I turn off the float. I check my email, and as you can see, it says Team Aerobicon. I created a Gmail account specifically for it. I'm gonna leave my teammates to talk more about that. I could just keep talking about this. I really enjoyed this project. So anyways, the text is pretty plain and simple. It basically says you need to seek professional help to fix the tank or the flowing of water from tank 2 to tank 3. And then this next time around, I demonstrate that F2, F3, and F4 turn on. F4 is the top float. There's, like I was trying to say earlier, we want to have a float above F4 that's independent, has its own circuit to turn on the pump. We just went past F2, it turns on. We just went past F3 and F4, and they turn on respectively. And you can keep seeing that by the console. So then here within another minute, it goes and checks the to see if it needs to send an email. And of course, F4 is on, so we have to send an email. Within a minute or so, I'll go check my phone and it'll show that there's more emails. Also, you'll see more emails. You'll see actually 3 emails and referring to tank 2, and then 1 email from tank 3. If you look in the CLE right now, it says the F1 is on. I had accidentally bumped the float and I didn't realize it until after I went to go check the email. So that's why you see 2 additional emails. So give it a second. There we go. So second tank is the top one, and then the third tank is the bottom one. It's kind of hard to see, but it says relatively the same thing. And I have a formatting issue if you didn't see it in the text. So like we still have little bits and pieces that we need to work on, but overall it functions the way we like it to. This here I'm displaying that the, you can't really see it too well, it's my fault, that it was outputting to the console. And then I'm going to demonstrate that we can turn on and off the LED light using the test pump button. So it should be, I believe it's on F2. No, it's on F4. We had raised it all the way up to F4. So I'm going to show, yeah, they're all on. So it's on F4, and I'm going to show that using the magnet, it'll come back down and turn off all those flags as the water lowers. And then when it reaches F2, it'll turn off the pump. That's the way it's coded. So there should be 2 criteria to turn it off. One, if the user set, this is another thing I personally want to implement. We want to have a user time window so that the user can say, yeah, we want our pump to run for 30 minutes or something to that degree. So it'll go out and check it if within that 30-minute time frame, and if it hasn't reached F2, turn off the pump. If it has reached F2, still turn off the pump. But what that will allow is if it's above F3 and it pumps down and doesn't reach F2, it'll still turn off. So now, like I said, I was just demonstrating that the read switches were working correctly with the CLE. Oh, and then the LED light was reflecting the changes properly. So yeah, the last one is F2. It turns on, even after you turn off the pump, it needs to turn back on immediately because that's where the float should be, at that water level. And I think in here I'm just displaying that, once again, the logs are, you can't see it, I'm sorry. I wish I would have caught that in the video. Oh, there we go. Yeah, so once again, it's a formatting issue with our CSS. We'll have to work on that to make it look right, ideally in a list. But based on the user input, it'll say the pump was turned on, the pump was turned off, and it gives the time. And then once again, there's a formatting issue in the last one, but you know, it's not gonna be perfect, but we're working towards making it as perfect as possible. And we have a few more minutes. Edit settings. Oh, and I believe here I'm demonstrating the actual LED light. Yeah, okay, so I'm raising it up. It just passed F2. Hit test pump or something degree, and the LED light is on. That little box right next to the LED is the relay. So it should be fairly easy to integrate this into our system. But yeah, that's the end of it. I believe now I'm going to pass it off to IT.
Me. Hi, everyone. So I'm going to be talking about the backup plan today. So as of right now, we're backing up our code, our customer information, our financial information, our sales data. As we grow, we're also going to back up employee data, but at this time, we're all volunteers. So we're going to be doing different kinds of backups. We're going to do a full backup every 3 months on Google Drive and on our hard drive that's going to be stored off-site. And we will do partial backups weekly and daily, depending on the amount of things that we are changing. We're also going to be testing our backups. We're going to do a full backup test every 6 months or whenever we decide necessary. If we were to have to recover part of something and realize that it's not recovering part completely correctly, we would decide to do an entire test. And we'll be testing our file recovery, our physical recovery, and our data recovery. And now we're going to move on to the backend services. So the transfer of data used in Aerobicon is very unique. The data will be handled by the client's Node.js server that runs on the device. The device will hold a local web page that will allow the user to set up and update their settings and view their past and current log files. The server will also be using the GPIO pins to scan for input from the float switches, queries, and from the Open Weather API. When applicable. The activation of the pump and recording of the activations to a log file. Currently, we're going to store the user's settings and log files under a locked admin file on the Raspberry Pi. The admin account will be set up on the web page within the server. Once this is done, the client will be able to make edits to their settings or any other services such as the float switches or pump activation time. The user-specific settings will be stored in the web page that is hosted by the Node.js server. And get stored in a file on the Raspberry Pi currently, the Proton board. It will be stored in the Node.js server directory named user settings. The settings will include the client's desired activation time, the city and state that the aerobic septic system is located in order to accurately pull the weather data, the user's name and email that will be used for alerts, such as the tank being too full or not running properly. When the pumps are activated, they will trigger a timestamp log file that will be stored as a text file in the Node.js server directory. The input from the septic system will be in the form of on and off signals from multiple float switches that are installed in the tanks. The float switches will indicate the water level of the second and third tanks. If the tank sends an on signal, it means the water level has reached the float switch. Each septic system typically has a maximum of 4 switches total, with about 2 switches per tank. This can be adjusted if it's a unique tank or a unique system that has more than 3 tanks, but the average one only has 2 tanks. So one switch will indicate that the tank is full or almost full and needs to be pumped, or that the tank has not been pumping properly and needs maintenance. The input will be transmitted through the pins in the device and read by the Node.js server that is constantly running on the device. That's the way that we're doing it currently, but as we're moving forward, we're looking at implementing a lot of AWS features for things like log storage, user settings and storage, our registration and login portals, our email notifications, and potentially AWS to push updates to the device where necessary and use it for our software updates and backups. And now Mason is going to talk a little bit more about what we need to go live.
All right. Thank you, Megan. So for some of the tech needs required for us to go live, we need AWS website hosting. We did this because it's our most effective and user-friendly way, and it also includes multiple different components that will assist us as our company continues to grow. AWS database system and cloud. We plan on using Amazon relational database services. And for our cloud, as Megan mentioned, we will be using a Google Drive with frequent backups. And as we continue to grow, move on to the AWS cloud database for backups in order to make everything a lot less difficult. PayPal subscription, we chose this route because it allows secure payments while only charging a small percentage for transactions. In addition, we also are able to send and receive invoices as well as collect payments in person and online. Also Shopify, this e-commerce platform will be our online storefront. It is affordable, flexible, and designed user-friendly. It ensures consistent experiences for our users no matter their mobile devices, and allows them to customize their systems to their needs and wants while also giving room for growth. And our assorted hardware, I will have to talk about on the next slide, please, includes float sensors. We want to, before launching to the market, adjust the size of the float as well as the layout. Also be sure it is easy to integrate in the user's current septic system, excuse me. Proton particle, this is industry standard, much cheaper than our current Raspberry Pi as well. It includes a Wi-Fi application that allows any mobile device to set up their system with Wi-Fi connectivity. And it also simplifies the management of the device and allows the user to control the system at their fingertips. Installation process, it varies based on your type of system. So you have your new system or your pre-existing system, which would have connected tank floats, disconnected tank floats, or mixed tank floats. You would detach your current timing circuit and connect the Aerobicon floats to the general input output pins on your device. And you place your floats in the tank at your desired height, and you wire them to the pump circuit. You would switch the power on and test and make sure everything is running smoothly. And I will now pass on to Josh to give you insight on the business plan.
Good afternoon, everyone, and thank you, Mason. We believe that we have a unique product in this marketplace that can create value for potential customers. And our value proposition shown here was created around that belief. As Justin previously touched on, with the Aerobicon device, aerobic septic system owners can replace the alarms and timers currently available with a more robust solution that users can view and operate from virtually anywhere. Justin, if you hit the next slide for me, please.
Sure.
During the process of deciding how to sell the product, we decided to go with a multi-sided market strategy. On one end, our end user segment consists of current homeowners or property owners that are looking to replace their current system or upgrade their system, and potential new homeowners that may be looking at an aerobic septic system for their property. In Texas, the Commission on Environmental Quality estimates that about 20% of new homeowners in the state choose an aerobic system because they can be installed almost anywhere, and in some places that normal septic systems can't. On the other side, our customer segment will consist of licensed dealers and installers of aerobic systems. Much of that decision to adopt the strategy was due to the fact that septic systems have to be installed by licensed and bonded dealers of those systems. Next slide for me, Justin. This brought up an interesting situation, which was how do we convince septic system dealers to keep product on their shelves? And the best way to do that is to offer the potential for maximum earnings, which brings me to our distribution model. Under this plan, we will sell our product to septic system dealers at a price of $200 per unit. The dealer will then offer the product to end customers at our suggested retail price of $300, which is comparable to existing products that are currently available, such as timing switches and controllable panels that offer much less functionality than the Aerobicon will. Under this strategy, the septic system dealer makes 50% gross profit on each unit sold. This gives us a strong advantage in breaking into a new market, and we have also planned for additional possible revenue streams, which Mr. Davis will now discuss.
So for our revenue streams, we will rely on these three. With transaction revenue, we would have direct sale of each Aerobicon device at a price point of $200. The Aerobicon unit will only be sold directly to licensed septic system installers. And our suggested retail price for each unit is $300, a 50% gross profit margin for the reseller, and is comparable to similar septic system control panel units that are currently available in the market. Next, we have service revenue. We will offer post-installation technical service to end users at a rate of $50 per hour. This rate is well below the current hourly rates for similar support in the East Texas area. And lastly, we have recurring revenue. The Aerobicon device will include a 90-day limited warranty with the option for the end user to purchase an annual maintenance plan for $50 a year. For our growth strategy, we plan to start with a lean operation with 8 employees and partnering exclusively with licensed septic system installers in East Texas. Our goal is that through steady sales, we can look at expanding into other territories, beginning in Texas, with the possible expansion into other states, hopefully within 5 years. And for our marketing site, the site is a WordPress site hosted on AWS with the help of Bitnami. We have information on what the device does, as well as a searchable map showing septic system installers and their information using OpenStreetMap. We also have a contacts page with phone numbers for our business and for customer support, as well as the email to contact us and links to Aerobicon's Facebook and Twitter pages. And as for planned features for the website, we expect to implement a forum for questions and for gathering bug reports, which would likely be set up using the BBPress plugin. And now if there are any questions, we will be accepting them.
So earlier in the development section, you showed the magnet. Does that transmit the signal to the Pi back at the timer switch?
So each reed switch is connected on its own circuit, and the reeds. So if you want to know the logistics of a reed switch and the magnet, all I can really tell you is that inside the reed switch, they're like this. And so within the presence of a magnetic field, they'll connect and complete the circuit. So in essence, they're each on their own circuit, and it feeds back into the Pi and the GPIO pins in the correct places. All we did was replace the float switches with the reed switches. That's, if that makes sense and answers your question.
Yeah, it does actually. Actually, that makes sense. Thank you.
Why did you choose to use
So I have a question
Drive for your backups?
We chose to use Google Drive in the beginning because it let all of us be able to work at the same time and upload things as we were working, while still having keeping everything we were working on secure and updated.
If I can jump in, one of the things that Shane and I ran into very early on in development is that we couldn't really find a good IDE that would work well with programming the different types of files that we needed. And we had kind of wanted to use something sort of like GitHub where we could do easier code sharing. But because we ended up having this kind of difficulty finding a good solution, we ended up using Google Drive to facilitate collaborating on our code. And at that point, it made sense to handle everything that way as well.
Yeah.
All right. Thank you.
Mm-hmm.
So I was going to ask a question. What kind of issues did y'all have with the coronavirus? Or what kind of issues did y'all have like setting up your?
Really, it's just facilitating parts. That's really what it amounts to. Off the top of my head, I'm running a little empty. I stayed up very late trying to try to integrate, because I was kind of torn, because I'm gonna go off on a tangent real quick. I was trying to integrate the device, and I wanted to be able to demonstrate the integration or the integrated device to y'all. So it required an update of the presentation, in which it took like 5 hours, set at 5 o'clock in the morning, and in the end, ended up recording just a few hours beforehand, but we made it work. Long story short, really it's just facilitating the parts. That can cross my head, or that crosses my mind. Justin, or Megan, if anybody has anything else that they want to add.
I'll add to that a little bit. I know that we were all really looking forward to actually installing the device in an actual septic system, but due to the virus, we could not get an electrician to come and pull that cable that we mentioned because it was considered non-essential. And so I think we were all pretty disappointed when we didn't actually get to install it the way we had first envisioned.
So I actually have a question. So during the development phase, I think Shane, you explained the logic of how the switches are being activated. So, well, could you go over that real quick? Like, give me a summary of what is the logic for the F1 or S1, S2,
yes,
S3?
Yes. So so you have F1, 2, 3, and 4. F1 is the one float that's inside of we'll say the first tank. F2, 3, and 4 are in the last tank. If F1 is up, so if the water level is made, the float raised up to the top, that means that water isn't moving from that tank to the next tank, which is problematic. So send a notification to the user. F2 and F3 are to help control, it's more or less the weather related stuff. So if F2 is on, you can pump. If let me think about this. If F2 is up, you can pump related to the weather. So if it's not raining outside, if it's not raining outside, pump. If it's raining outside, don't pump. F3, if it's raining outside, still pump. If it's not raining outside, still pump. F4 is the notification for the tank is full, and effectively there's going to be an F5, but it's not going to be anything that we'll have to put in the code and programmatically do. It's going to be its own circuit, and it's just going to turn on the pump, regardless of what the PI says. And that's if the float raises up so high, or the water level raises up so much, it'll just go ahead and turn on the pump.
Okay. One of our reasons with that fifth one that he's mentioning is so if the PI or if the Aerobicon device stops working for some reason, maybe hardware failure, the tank will not just sit there and endlessly fill. There will still be some sort of pass through that allows it to activate the pump and empty the tanks when necessary.
Got it. Thank you.
So on the business side, do you foresee a problem with the fact that, people, they replace their septic tanks or check or would do this type of work, once every decade? Most people don't even think about it. So are you do you think you might need to do an advertising push to get people, or are you just hoping what is your plan for as far as customer base goes? Because it seems like it would be a limited customer base and a very few and far between time-wise that you would get orders.
Yes, that would be as hard to reach customer base. And we would have a Facebook page to reach out. And we'd also advertise on Facebook, and we would have a Twitter page set up for that as well.
Patrick, I'll field part of that too. We do have a active and working Facebook and Twitter page right now, but also part of the initial strategy would be cold calls and going door to door to these system installers and showing them what our product can do and how they can make money off of helping us sell it.
Okay, so similar to like the home security salesmen that come by every now and then. Okay.
Correct.
Something else to add real quick, and I want to preface this. They didn't mention this because I haven't relayed it to them. I have ideas that I would like to implement. So one of the other ways that we could potentially address their customer base would be specifically allowing for a septic system company to have access to user information I should elaborate regarding just the log files, or maybe additional things that we will want to implement on the CS side to be able to track how a septic system is monitoring or functioning, and that can be relayed back to the septic system of their choice, or septic system company of their choice, and allow for them to give better input and direction as to how they need to approach each situation, if that makes sense.
Okay, so kind of
So
selling knowledge to an already established septic company. Okay.
Yeah. This is something I haven't relayed to any of them. It's just another idea that Dad and I have been talking about. But ideally, it'd be exactly how Josh and Cody had mentioned it.
Right. Okay.
All right, and thank you for that.